About a year ago, I bought this old DeWalt Radial arm saw with the plans to do a full restoration and make it a regular use tool in my shop. Aside from just being a beautiful machine, properly tuned, an old radial arm saw like this can still provide very accurate cuts. When I bought the saw for $50, I did turn it on once just to make sure it worked, but as you can see, the wiring was a bit terrifying. The guy selling the saw actually had the original manual and repair parts book. When I started this project, I thought they'd be a lot more useful than they ended up being, but it was still really cool to have. I had already removed the table before I started this video, but the next thing I started removing was the leveling brackets that hold the table assembly. One of these bolts did break during the removal. I was able to get through the whole disassembly without breaking anything that wasn't totally replaceable though. Prior to starting this project, I did about zero research on how to take one of these things apart or what other people had done to restore them, but I found that this as a machine was pretty easy to figure out. For the most part, disassembly went pretty smooth, and I got the entire thing down to pieces minus the motor in about 2 hours. This arm locking bolt that I'm removing right now is not original. Getting the vertical adjustment screw removed and fully disassembled was probably the worst part of this. I couldn't get that pin out, so I decided to move on and just remove the entire pillar from the base. At this point, I still hadn't been able to get the elevation adjustment knob removed, and I couldn't get that bronze nut off the jack screw until the arm was off the pillar. Unfortunately, this screw completely rounded out. I had to get fairly aggressive to get this rivet removed, and in the end I ended up drilling it off from both sides. There was a lot of frustration, and I kind of bounced back and forth between trying to get that handle off and trying to get this screw out. I ended up having to weld a bolt onto the screw so I could get a wrench onto it. Though on the first try, that bolt snapped in half. I turned my attention back to the elevation crank. Since I had drilled most of the pin out, I was able to now just pound the jack screw down through and get the handle off. I tried again with welding on a bolt, and this time it worked great. Getting that arm and column assembly disassembled was about the most difficult part of this entire project. There are several grub screws with jam nuts on this old saw. These ones here allow adjustment for something called the heel of the blade, and if I broke one of them in the aluminum casting of the trunnion, it would have been a disaster. Luckily, everything came out okay. This locking pin right here was one piece I just could not figure out how to remove. I think it was pressed in, and in the end I opted to just leave it in place. The badges and scale indicators were all riveted on. They were steel rivets going into cast iron, so they were a lot harder than the iron itself, and in the end I ended up having to just grind or drill the heads off to be able to remove the badges. These two rivets here I was able to just pound through once the heads were removed, but the ones on the badges I ended up just kind of filling in and then re-drilling new holes when I put the badges back on. I wanted to reuse these, so I tried to remove them as carefully as possible. They didn't come off too bad, but as you can see they weren't great and I ended up redoing them. This was the result of one afternoon, and the next morning I got right into the restoration. At this point I had no idea what kind of paint DeWalt used back then, so I did a lead test first just to make sure I didn't need to do any other special precautions. It turned out to be negative. I don't have things like a parts washer or a sandblaster like the really good restoration channels do, so I did this the way somebody in a woodworking shop would do it. Elbow grease and chemical strippers. So my internet research taught me that the kind of paint DeWalt used back in the 50s was something called Zolatone green. Zolatone is a very durable textured paint that you can still buy today, but unfortunately not in the seafoam green. It came off pretty well with the stripper, though some areas required a few rounds, and the primer that was underneath proved to be extremely durable. So in a lot of cases, I just left it in place. I figured if the primer had lasted 70 years and survived the chemical stripping process and was hard to sand off, it'd probably be better if I just left it on there because it was protecting the metal more than anything I was going to spray on would. I thought about doing an electrolysis bath rust removal, but in the end I decided to just opt for the chemical rust removal stuff. You can get this at Home Depot in the paint section. Most of the lighter surface rust came off in one go, but there were a few areas that needed a couple applications. Luckily, no part of this saw was so severely corroded as I couldn't just take it off with this stuff. As soon as I finished stripping and rust removing every single part, I taped off all the areas that didn't need paint, and I sprayed on some primer as soon as possible just to try and prevent any flash rust. Priming the arm itself though was kind of a waste because a few days after I did this, I decided I wanted to sand it down and try and get the casting as smooth as I could without resorting to like body filler and really going nuts. I also polished up an area that is not going to get painted because it's where the clamp goes that actually holds the carriage assembly in place when you're using the saw in ripping mode. The upper carriage assembly had some rubber bumpers that were too deteriorated to keep. They were riveted on, but luckily I was able to get them and the rivets that held on this little indicator needle pulled off without any real problems. The motor cover and blade guard are made out of cast aluminum. With all the textured paint removed, it became clear that the aluminum castings were a little rough and could have been a lot better. I didn't want to paint the handle, so instead I polished the aluminum up as much as I could. The blade guard had a little bit of damage that I couldn't blend out, so I fixed it with some JB Weld. base was probably the most rusted and most cumbersome piece to work on. I got the outside pretty clean, but I didn't spend too much time trying to get the inside clean because it was just a little hard to access. This metal was flash rusting so quickly that eventually I decided to call it quits and just move on and hit everything with some lightly rusted metal primer. The jack screw went through the chemical rust treatment before I used the wire wheel. After this, I sprayed the jack screw down with some Boschio T9 spray, and then it got greased upon reinstallation. The column itself wasn't too corroded, but it was pretty discolored, and I'm pretty sure through the course of all this I removed whatever remaining protective coating this metal had on it. I ended up polishing it up as best as I could, and then I coated the whole thing in the T9 spray. I held off on pulling apart the motor for as long as I could because this was one of the more intimidating aspects of this entire project and something that was definitely outside of my comfort zone. The video I took of the disassembly was very useful when I put it all back together. I managed to crack the cast aluminum fan in a couple places during the removal, but luckily it was still in one entire piece. I scoured the internet and could not find a replacement. I ended up fixing the original one with JB Weld, though I did try to 3D print a few models out of nylon and PETG, but they were not strong enough. If it proves to be a problem in the future, I'll send that file to Send Cut Send and have them mill me one out of aluminum. I was really careful stripping and rust removing the center part of the motor because I didn't want to screw up any of the coils. A project like this is a great reason to learn how to do something new, and on this one I decided I was going to learn about electroplating. I wanted to coat these parts in polished nickel, but before I could do that I needed to clean them up, remove the rust, and then smooth them out as best as I possibly could. There's lots of good tutorials online on how to do this, and I opted to just get some pre-made nickel plating solution and use a small DC power supply to plate the metal. There was a little bit of trial and error, and a few pieces were done more than once, but after plating and polishing, they came out really nice. For reference, here's one of the first pieces that I did what it looked like before, and here you can see it with the others after. Other parts like the capacitor holder got plated, but I didn't worry about polishing them up too much. I used cold bluing solution on all the parts that didn't get plated. This was pretty new to me too, and I probably could have gotten a few of these bolts a bit cleaner before I did the bluing. These two pieces in particular I wanted to polish up, and here was the process I used. I could have taken this over to the buffing wheel at this point, but to show that you don't need that, I used a little bit of diamond sharpening paste and a piece of leather to do the final shine. Probably could have gotten it a little bit shinier, but this was good enough for me. I repainted the embossed areas with a bright red enamel. The scale indicators were spray painted red. I wanted the badges to really look good and pop, and the originals were not in that great a shape. I decided to remake them, so I polished up the back sides of the metal pieces, and then I created vinyl stickers in silhouette. I thought they came out great, and here's a before and after. I wanted to add a little badging to the steel rear motor mount cover, and I did that with some laser marking spray. I didn't want to rattle can the final finish, and I already knew that trying to do this in the actual Zolatone green was just not going to be practical. I settled on an oil-based enamel in gloss white. Before I could spray that though, I had to spray on a coat of white metal primer. This project was the first time I ever tried spraying oil-based anything, and I ended up with a lot of orange peel. However, with the industrial look of the tool, I think it actually works pretty well. A little bit of rust had developed underneath some of the tape. This was very easily removed with some Scotch-Brite, and then I just treated the area with some T9 spray. The first thing I did was add some feet to the base. The underside of the base was the most rusted part of the saw, and I can't help but think maybe it would have been in a little better condition if it had feet, so it wasn't constantly full contact on whatever it was sitting on. The base of the column went back together a lot easier than I was expecting it to. That little bronze wedge and the set screws actually provide the friction control for how hard it is to raise and lower the column. As you can see by the iPad on the workbench, I was constantly referencing the disassembly videos. Before I could put the arm onto the column, I had to get the carriage fully adjusted. 2 of the 4 roller bearings are held on with these eccentric bolts. They still bore the witness marks from the grub screws, so it was pretty easy to figure out which side of the carriage they went on. The eccentric shape on those bolts allows the rollers to be rotated outward to eliminate any play in the carriage. For me, one of the most fun aspects of this entire project has been completely taking this thing apart and putting it back together and fully understanding how every single mechanical element works. I took the time to reinstall the DeWalt badges before putting the arm back on. Personally, I thought these turned out pretty sexy. That stubborn column cap went back on with some new hex drive bolts. I 3D printed some new carriage bumpers out of some TPU filament with a 50% infill, which worked really well. Many of the pieces that I'm reassembling here are all to provide adjustments for the calibration of the saw. I'm not going to get into how that's actually done because there was a much better, more informative video than anything I'm going to put together that I used to calibrate this one, and I'll put a link to it in the description. And I don't really show it in the video, but all the bearing surfaces were lightly greased before the parts were put together, and anything that needed lubrication got it. Here you can see why those little bumpers on the carriage are important. This badge here is not an original feature, but I made it and I thought it looked cool. The original table had seen much better days, so I needed to make a new one. I opted to use a pre-made birch butcher block countertop. This may warp in the future, but if that happens, I'll just reflatten it and add some C-channel to the bottom. It was a bit too large to try and drill on the drill press, so I had to use kind of a roundabout method to get accurate holes. I didn't film the restoration of the table rails, but I can tell you they were very rusty. The rust came off and then I spray painted them silver. The screws themselves got blackened. The table's held on this way because it needs to be able to be adjusted to be perfectly parallel to the arm in all angles. That particular adjustment was the most time consuming and biggest pain in the butt in getting this saw all calibrated. The fence that I'm using right now also is just going to be temporary until I can make a better one. I 3D printed some strain relief grommets for the wiring. The cord comes into the arm and then the hot wire is interrupted by the switch. Then all the wires are terminated with some female end quick disconnects. I wanted to be able to remove the motor and carriage assembly from the arm in the future if I ever needed to without having to mess around with the wiring too much. I also 3D printed this little bracket to hold the cord to the column and keep it out of the way and safe. I also printed these little dust caps to go inside the bolt holes for the table to keep stuff from falling in there. The blade angle clamping lever was probably the last piece that went onto the saw itself before I put the motor together. Like I mentioned earlier, I just JB welded the cracks in the fan. Time will tell if that was a bad decision. The bearing that came out of this motor needed to be replaced, and sourcing one proved to be a little bit difficult. I ended up finding it on eBay, and it wasn't as expensive as it could have been, but it took a little while to get there. I found it a little bit odd that the motor reset switch interrupts the neutral wire, but I did confirm with some online forums and how the thing was originally wired, and that is apparently the correct way to do it. The only reason I used a quick disconnect on this wire is because I didn't have any splices handy. I made some fixtures out of some scrap wood and used my jaw horse to squeeze everything together and get the bearing seated. Like I mentioned earlier, prior to taking this saw apart, I did verify that the motor worked, but I really had no idea if I was going to be able to take the thing entirely to pieces and put it back together and have everything go right the first time. Turns out I got lucky. After making sure the wiring did work, I installed a little 3D printed cover that I had made to keep all the electrics safe. I also 3D printed a little cover for the blade guard vacuum port, which is ordinarily only really used during ripping operations. After a couple hours of calibrating everything, I made the first cut. I want to figure out some kind of dust collection solution before I use this thing too much, but that's going to be the subject of a future video. That brand new blade though did go through these pieces of plywood like a hot knife through butter. And the cut was dead on accurate. I have to admit, I am beyond thrilled with how this thing turned out. As a reminder, here's what I started with, and here's how it looks now. I should have mentioned it much earlier in the video, but I'll take the time to do it now and say that radial arm saws, while incredibly versatile, are also kind of some of the most dangerous woodworking machines there are. I'm only intending on using this for 90-degree crosscuts, which is probably its safest mode of operation, but just so you can see what these things can do, I'm going to kind of move everything through and show you. You can move the blade parallel to the fence so you can do ripping operations with this saw. Mine's actually missing the anti-kickback pawl, so I'm not even going to try to do it. That's what's supposed to go in that little hole on the blade guard just below the vacuum port. So with these saws, you can set the motor up to be able to feed from either side, but if you actually decide to try and rip a board with a radial arm saw, you want to make sure you're always feeding it from the opposite end than the way the blade would hit if you were cross-cutting. I would highly recommend watching some safety and use videos on a radial arm saw if you were thinking about getting one. You need to find one on the secondary market though, because these things have largely been discontinued by every manufacturer. One of the more wild functions is you can take the motor and put it vertical. This can allow you to do things like cut tenon cheeks, but I do not think I will ever even try this. You can also take the blade and guard off and install different things on the spindle like shaper heads. My saw actually came with a few and I will not be trying them out. This seems like an example of trying to make a machine just a little bit too versatile. So here's some reminders of just how far this saw came. While the restoration is complete, I would not say I'm done with this project. Next up, I need to make a stand with some folding wings and incorporate some safety features into the saw and some dust collection. So look for that video in the future, and if you made it this far, as always, thanks for watching.